another morning, another stand-up. Let's hit it. So just going to the Discord, we're going to the JavaScript algo section, checking out the 27th of the 27th challenge, January 27th. Awesome, let's go ahead and do it. So our prompt says, given two elevators named left and right, in a building with 3 floors numbered 0 to 2, write a function elevator accepting 3 arguments in order. Left, the current floor of the left elevator. Right, the current floor of the right elevator, and call the floor that called an elevator. It should return the name of the elevator closest to the call floor, left, right. So okay, so this is kind of what I'm thinking. Grab a Scala draw if I can find it, if I have it. There it is. Thought I did. Oh, come on. Come here. All right. So what I'm thinking is we have an elevator. Well, let's do a building. We got a building, and we have an elevator line. Right. We can just so these are the floors, right? And then let's go ahead and copy these actually. And do left. All right, so we have these floors, and then we have buttons on each of these floors, right? To call the elevator. So what I've noticed about elevators and using them is that if an elevator there might be different systems, but if an elevator is moving upwards, right? If an elevator is moving up and like from 0 to 2. So let's write this out. if an elevator is moving, period, right? And a call is occurs in the path, then stop. Then this elevator takes priority. So for instance, if elevator so if this elevator is here, and we'll do like starting points, right? Let's make this text like green, so we have like a consistent message here. If an elevator is moving and a call occurs in the path, then this elevator takes priority. And then we have an edge case. What if we have the other elevators doing the same thing at the same time? Ideally, we wouldn't want both of them to pause, you know. So this is assuming there's only one button, right? To call both. So I think, and it also depends on the traffic of the area. But what I would say is, so if they're going from 0 to 2, and this one's going from 2 to 0, right? I would have both pause if there's just a button, because this person may want to go up or down. We don't know where this person wants to go. That is unclear because there's only one button. If there was two buttons, one for this and one for that, the person can clearly decide this one's coming down and that's the way I need to go, so I'm going to click this button. So in this way, if we only have one button, then, you know, we have to, I think it makes the most sense to pause both, unfortunately. So and a call occurs if an elevator is moving to its floor and a call occurs in its path, then this elevator takes priority. If both elevators are moving and a call occurs if both elevators are moving and a call occurs, I don't think it tells us whether we have two buttons or not. Yeah, it's one call, right? So one button. If both elevators are moving and a call occurs in both paths, then both elevators priority. Okay. So that's if both of them are moving. What else? So this is if the elevator's moving. Now what if so what if this one's moving to 2? Like what if this is moving, but this one's at 1? Well, this one, I guess it depends on the initiation. So so let's define initiation, right? So like these are the different things that our elevators can do. Let's do this. Oh, no, I want this to be black. And then the list, I want it to be like red or something. So list of actions, we have standby. So this is an elevator that is just waiting. What if we do, so we have standby, and then the next thing is someone presses a call button or someone presses a button inside the elevator, right? Technically, the elevator will return to standby once the doors close. So let's add those notes for standby. I think it might make more sense to make this like a header at this point. And then let's do some purple text, why not? So standby, what is happening? You know, and I would just put active calls a second there. You know what that could be like something like a we could have calls that are like someone makes a call outside the elevator, and then once it gets to that platform, it's like on pen, like nah, it's too complicated. So the elevator doors have closed. The elevator has no calls. That's what standby is. So what about so um so this is my thought. Um you don't want to be, so you notice both standby and call are both standby and call are both have the elevator doors closed, and one is moving and one is not. Now this is a problem because if we have an elevator that's someone just got in and the doors are closing, and they haven't clicked the button and someone calls, it's gonna immediately start moving to whoever just called it, and we don't want that. So we need like a third one. What if we call it like door operation pending assignment? Yeah, that's a good one. So standby, we're waiting for an assignment. Elevator doors are closed, elevator has no calls. And now, just now I've defined an internal call. So we need to we can label this here. All right. Let's see what else we got. If an elevator is moving to its floor and a call occurs in its path, then this elevator will take the priority. I think this is important though. So right, this is the full thing, but it's really like this. So, right, because this is going to be 0 and we're fulfilling it to 1. And if a call is made after 1, like if we're at 0 still, then we can intercept. But as soon as we hit 1, then we cannot, right? So I think that's important. If let's see what else. If an elevator is on standby and another elevator What about this case? Okay, now if, what else? What if left is kind of have all of our cases building out here? I like that better. how many floors, options, what floor we are on, what floor are we going to if applicable, what floor we are what floor, oh, what calls are active. Yeah, how many floors, options, what floor we are on, what floor we are going to. What internal calls are unresolved and what external calls are unresolved. Okay. I've way over engineered this problem. But it was fascinating. It's something I really enjoyed doing, so there's nothing wrong with that, I don't think. So here we are. We have built this, and I think the only case that we care about here is this one. Left is standby, right is standby, closest takes priority. I think that's all we're working on today. But so let's look at all these cases. So both are standby. What happens? Closest is going to take priority. Left is standby, right is doing door operation. So left would take priority in that case, right? Left is on call, right is on call. Both elevators are going to stop. We didn't do standby call though. But it's going to be the same as this actually. Let's add it. I think that is a very valid case to add. All right. Closest takes priority, but if it's a tie, call will take it. If they're the same distance and calls in movement to it, then this is only this is only 3 floors, and that's all I'm considering here. If this was a much larger building, and I would also want to look at the traffic too, I think. Okay. So we have standby, standby call, standby door operation. We have call, moving towards. And pretty much everything else is we have to wait. So moving away, door operation, where we're waiting for a call on the inside. Like this is kind of like a pause, right? Door operation is like waiting for internal commands because internal will take precedence over external. So could you imagine an elevator system where the external are always takes precedence? You get in an elevator on the first floor and you're like, and it starts moving to the second floor, and you're like, no, wait, I wanted to go to this. I was trying to figure out where I was, and then you guys get on the second floor, and then you get called to the 0 floor, but this guy wanted to get off here. Yeah, that could be pretty. It could be a good joke. All right then. I think we have it all written out. I'm going to move this over to the right, and we'll actually work on the code now. That was good. I like a visual of the of what I'm working on personally. I think it's super helpful to have that kind of visual. So, all right. So we have 2 elevators named left and right in a building with 3 floors, numbered 0 to 2. Right end function elevator accepting 3 arguments in order: left, right, call. So this is holding the state for the current floor. This is holding the current floor of the right elevator, and then call is the floor that called the elevator. Now, we're basically assuming there is no internal calls. So that's fine. So we're writing a function of who takes precedence, or who takes priority on an elevator in a case where both elevators are equal distant from the called floor. So who takes precedence? So these elevators could be, we're just checking state, right? Because they could be in motion. They could be on standby, and we could engineer this differently. So takes priority on 2 elevators. See, but this is where this breaks apart, right? Because if elevator on the left, right here, if we look back at this example. So, and I'm not, this is a great practice exercise. It's not, this is just showing the limit. I'm just showing some limitations to this problem, right? So if the elevator on the left is on 2 and the elevator on the right is on 0, right? No, I think what I was thinking of is this. So if they're both on 1, but this, let's say the right is going up and the left is going down. What our function here is, what our function that we're building is going to do is saying, hey, whoever's closest takes priority. But what if this person wanted to go like down? You know, what are, like, I have here that bullshit open, but I don't choose the elevator to the right. Okay, if they're equal. All right, so if left is if left is what? So left is going to be a number 0 through 2, right? And so is right. And then the call is going to be 0 through 2. So if I'm on, so if left is, well, we can take care of this. It wants me to return the string right. Okay. Could we just do an else? Hmm. So if they're equal, we're going to return right. Done. How do we tell which one's closer? Which one is closest to, for the first case, which number is closer to 0? Is it 0 or 1? Hmm. I know how to do greater than or larger, less than or greater than. But how do we do? So this is a good point too. equally distant does not mean equal, like directly equal to, right? Like this is true. So like for instance, down here in our test case, but then we also have this example where we have 0 and 2 and the call was on 1. They're equally distant to this. So I can evaluate whether they're less than or greater than, but how do I evaluate how many integers are between my current integer? So this is the crux of this whole problem. How do I evaluate the amount of integers between two given numbers? I feel like there's a method for it, but if there isn't, I could subtract I could find the bigger number. So this is, if there isn't a method, this is how I would think I would do it. First, find which number is the largest number. Subtract that number from the other number. Or subtract a number from another number. Make sure the result is a positive number. I can do this. This I can do. So for instance, we could say what is it called? Make a it's like absolute math.abs. Yeah, the absolute value. And now we have the distance. The distance from the left and the distance from the right. So if we say if Actually, we can just do else, I think. Because if right elevator is greater than or equal to, we're gonna still choose right. All right, cool. So 0. All right, whoa. Yeah, this one would be further away. We want it. We want it. Yeah, that makes more sense. Yeah. Okay, cool. Is that it? Bada bing, bada boom. Well, let's go ahead and see. And this is what I'm talking about. You don't need methods. I love when I can write out something like this and find two different ways. Alrighty. Save this bad boy. What a fun exercise to start off the day. You know what I'm talking about? I love it. I got a CD into that. There we go. Yeah, I'll grab this. And you better believe I'm saving that photo. That beautiful thing. It's very possible we'll hit this in the future. So definitely want to save the work. Beautiful. So we'll get add all. Man, I am those commits. What a great warm up. All right. Now let's go to our GitHub. Go to my Scala draw. Take a picture of this beautiful thing. All right. Can exit out of that. Just add our picture down here at the very bottom. Well, let's do this. Let's put it down here. Beautiful. Go ahead and add our solution to the Discord channel for the solutions. So it's pretty dang cool. All right, let's find our next one. Should be on our list. All right, that's all taken care of. Quit that. Again, I'm still working on that Udemy course. I'm trying to finish that up as soon as I can so we can get finished on our blog time exercise. So I'm going to be working on that for the rest of the day and see how far I can get. We'll talk to you.